We're going to start with M1.2 in the syllabus, which is perimeter, area, and volume. So this is the part of the syllabus. I'm just going to give you a second to read it. So we're looking at a couple different things here. We're looking at practical problems, Pythagoras, scale factor, surface area of solids, prisms, cylinders, spheres, and composite solids, volume and capacity of solids, same thing, units of volume and capacity, perimeters and areas of irregularly shaped blocks of land, the trapezoidal rule, and then just those variety of context questions. So how do we do this in a bunch of different ways in real life applications? Okay, so we're going to run through a couple definitions to start us off. First things first, what is perimeter? So perimeter is the distance around the boundary of a closed figure. Area is the size of a surface. So this is some pretty basic stuff that I think you guys would already know. If we take a look at this, I've got my little laser pointer, this shape here. If we'd add these four sides together, we'd have the perimeter. If we multiplied this side by this side, we would find the area. Pretty basic stuff. This is super, super important. It's why it's in a beautiful red box. These are our formulas for perimeter and area. Now, if you take a look at our summary sheet, I think it's flipped to you guys, you'll see that we have length, area, surface area, and volume on our summary sheet or our formula sheet. We have 1, 2, 3, 4, 5, 6, 7, 8 formulas, right? They don't tell you what these formulas are. It just says L equals theta over 360 times 2 pi r. It's your job to know what that means. These are the formulas with the object of the formula in front of the equation. So rectangle equals length times breadth, parallelogram base times height, triangle half times base times height, rhombus half times product of diagonals, kite is half times product of diagonals as well, trapezoidal rule or trapezium, half times height times sum of parallel sides, which is also h over 2 brackets df plus dl. We'll get into that in a minute. Circle, pi times radius squared, sector, fraction of the circle, theta over 360, times area of a circle, circumference, pi times diameter, or 2 pi radius. These absolutely need to be known. These are required knowledge. Sometimes they give them to you in the question, not all the time. So it's very, very important that you know these formulas. How are you going to learn them? Putting them on flashcards is great, whatever. It's just practice, honestly. Doing the questions over and over again is how you're going to get these formulas into your head. So I would highly recommend practicing questions with these rather than just trying to memorize them on a kind of rote learning basis. So you don't need to write them down on, little sticky notes and read your formulas out to yourself every morning before school. You just need to do practice questions. That is how you're going to learn these. I would recommend, I'm going to give you a second, I'll move my little laser pointer. Screenshot this or save the slide or whatever it is, because it's very, very important that you come back to this. Okay, so here's another helpful one because it's sometimes students forget, what is a diagonal, what are the diagonals or what does a kite look like? So take, for example, fraction of a circle. This one, you would be looking for 270 over 360 because you've got 3/4 of the circle. Height times divided by 2 times sum of diagonals. This is a trapezoid. We'll talk about this in a minute. And it's important to remember diameter is just the perimeter of the circle. So this is all surface area. These are our 2D shapes. So measurement, find the area of the shape pictured. So we have the area of a triangle, half times base times height. So how are we going to work this out? Because it's a right angled triangle in terms of, we have our right angle here. It's an easy equilateral triangle. It doesn't require any trigonometry knowledge. Half times base times height. So we're going to do half times our base, which is 8, times our height, which is 6. And let me get out my calculator. We get 24. Now, what helps you is understanding what formulas are doing. So what this formula is doing is saying, okay, if I had a square or a rectangle that had a base of 8 and a height of 6, that would be the area, right? But because it's a triangle, see how we could make the same triangle if we added this side and this side together? So it's telling you that half of the circle, which is where the triangle is, 8, 6. So the answer for this one, 24. Also got that written down. All right, so this is Pythagoras' theorem. A squared plus B squared equals C squared. So long ago, this magical Greek man realized that if you did the square of the two shorter sides added together, you would get the square of the longer side, which is the hypotenuse. So how do we apply this? We have the two shorter sides, 5 and 7. The longest side is always going to be opposite the right angle internally. So this only applies to right angled triangles. You cannot do this on non-right angled triangles. We'll get to that when we do more complicated trigonometry in year 12, which I believe you also do in year 11. But for now, it's very important that the hypotenuse is always opposite the right angle. So this theorem states that the square of the two shorter sides of that triangle are equal to the square of the longer side. So very simply, step number 1, you have to identify your two shorter sides, which are going to be next to the right angle. Hypotenuse, opposite the right angle. Then we just do 5 squared plus 7 squared equals C squared. So this is going to be 25 plus, oh, hang on, is that right? Yeah, 25 plus 7 squared, which is 49, equals the root of C squared. So 25 plus 49 equals 74. We have to square root that, and we get 8.6. So take a look at the answer. There we go. 5 squared plus 7 squared equals 74. 74 square rooted is 8.6 centimeters. Now, I forgot to write centimeters, very important, because then they go, what do you mean, bananas or something like that? You do always have to write the unit. It's a very, very, very important part of the equation. Okay, scale factor. So scale factor is a factor that we use to compare the size of two different shapes. So this is more of a real life analysis or application of a principle of mathematics. So for an example, if these triangles are in the scale 2:1, what are the measurements of the smaller triangle? So scales are read in what we call ratios. So this part is something to this part. It's saying that the first part is 2 times bigger than the second part. So if this is 2 circles, the second part would be 1 circle. So this triangle is twice as big as this triangle. So we just have to half all of the edges or all of the sides here. So it would be 5, 4, and 3, which are under those letters, as you can see there. If it gets more complicated, you might have to divide by like 3.5, or you might have to times by 7, whatever it is. But you just have to be able to read the scale. If it said the triangles are in the scale 1:2, which obviously doesn't look like it, you would have to double. So you do 20, 16, and 12. Okay, so we're going to move on to finding the surface area of 3D objects. So for prisms and pyramids, we add together the area of each side because these are mainly rectangle, squares, and triangles. So if we have a triangular prism that looks like this, well, that's not too bad of a drawing, you would have 3 sides, 1, 2, 3 rectangular sides and 2 triangular sides, right? So you're going to add the 2 triangular sides, so 2 of these together, and then you're going to have 3 rectangles that connect them, and you're going to add those together. So then you'd have 2 triangles, 3 rectangles, add them together, and you get the surface area of your prism. For other solids, we actually have formulas. So for a cylinder with 2 open ends, this is our toilet roll. It just looks like this. Oh, you know what I mean. Let me find you a cylinder with 2 open ends. Here's a hair roller. 2 open ends, you can see through it. This is a cylinder with 2 open ends. Our formula is area equals 2 times pi times radius times height. Now we're going to conceptualize why this is our formula. 2 times pi is giving us, times radius, is giving us this, times height is giving us how far down it goes. And that's our area, because we just need this piece that wraps around. Cylinder with two closed ends is going to look like, here's a dry shampoo bottle. Two closed ends, close on the top, close on the bottom. This formula is slightly different because we've got 2 times pi times radius squared plus 2 times pi times radius times height. So we're finding 2 times pi times radius squared is our 2 solid bases. We've got to find the area of 2 circles plus the same thing as up here. 2 times pi times radius times height, which is the bit that wraps around. The last formula to run you through is our sphere. Area equals 4 times pi times radius squared. So our sphere is going to, we always do a bit of shading to show that it's a sphere. Something like this is 4 times pi times radius squared. I don't exactly understand why it is 4 times pi times radius squared because it's kind of complex mathematics at this point. I'm looking around to show you a sphere. I think everybody knows what a sphere looks like, so we're probably good on that one. 4 times pi times radius squared. So let's go back to our formula sheet. 4 times pi times radius squared is there. Area equals 2 pi r squared plus 2 pi r height. Cylinder with closed ends. We don't get the formula for a cylinder with open ends. So we have to know that on this section where we get the cylinder with closed ends, that the cylinder with open ends, no 2 circles connecting, we would just have to cross out the first part of that formula. All right, so find the surface area of this prism. This one, we've already got the working out, but I'm going to walk you through it. So the first thing we're going to do is step number 1, what are our faces? We have 2 triangles and 3 rectangles. So we're going to work out our 2 triangles first. Because it's a equilateral easy triangle, we've got a right angle in the middle. We can just do half times base, 4 times height, 6. Now, because you have 2 triangles, you can either work that out twice and add them together, or you can just do 4 times 6. Because if you added these 2 together, you'd get the square, or the rectangle you would have anyway. 4 times 6 is going to be 24 centimeters squared. Now we need to work out our 3 bases. We have 12 centimeters on the base times 7 centimeters on the side. So this is actually the incorrect, we have 2 different sides. We have to work out the base first. So this one is 4 centimeters. So 12 times 4 centimeters to find the base. And we get 48 centimeters. And then we have 2 higher rectangular sides. So 12 times our 7 side here. 12 times 7 times 2, because there's 1 here and 1 here. We get 168 centimeters. So if we add together 24, 48, and 168, our answer is 240 centimeters squared. Okay, so more formulas that you need to know. Volume, the amount of space that a solid occupies. Capacity, the amount of fluid that a container can hold. So space that a solid occupies. I'm looking around for an explanation. So these AirPods hold a specific amount of volume, right? They occupy a specific amount of space. Whereas this container can contain a certain amount of fluid. It has a capacity. Its capacity is currently fulfilled by highlighters and scissors, but I could fill this with water and it would have a capacity. So the volume of a prism. Prism, we're talking about what we were just talking about. So we've got our rectangular, that's a trapezoidal prism of some sort. We've got our triangular, we've got our prism that looks like this, something like that. Then we have, so that's face area times height. So literally if you took a knife, I'm going to attempt to draw a knife here, and you cut down the middle, if it was a triangular prism, you would just have something that looks like this, right? Say the area of this was 13 centimeters squared. It'd be 13 centimeters squared times whatever the height was, 8. And that would be your volume cubed. That is for prisms. Now for cylinders and spheres, we do a different formula. Cylinders, volume is pi times radius squared times height. So let's have a look at our formula sheet. Pi times radius squared times height. Not on your formula sheet. Volume of a sphere, 4 over 3 times pi times radius cubed. We do get that. 4 over 3 pi r cubed. It's the bottom one here. I always remember anything to do with the 4 is a sphere. Okay, so let's have a look through some more important information. Capacity and volume also rely on these conversions. Anything with this red around it, I would say you guys need to write down or highlight or, screenshot. So capacity and volume will rely on these conversions. 1 milliliter is 1 centimeters cubed. So if you have a milliliter of water, it is, if you were to pour it into a mold of centimeters cubed, it's going to be 1 centimeter cubed, 1 physical centimeter cube. 1 liter is 1,000 milliliters, which is 1,000 centimeters cubed. And 1 kiloliter is 1,000 liters, or 1 meter cubed. So let's take a look at this example. Find the volume of this triangular prism. So our volume is going to be our area times our height. So how do we do this? We just take our area of our face. So think of it like area of the face times height, which is 12 centimeters squared times 13. 12 times 13 is going to give us 156 centimeters, and this is the important part, cubed. And we'll see 156 centimeters cubed. Okay, it's also, like I said, important to express your volume in cubic terms. Okay, trapezoidal rule. This is something that is very, very important to understand. We use this rule to calculate the area of fields that don't have a straight boundary. So this could be like a farmer's paddock. It doesn't have a straight line, but rather a curved line on the edge. This is where his gate is. This is where he keeps all his sheep. This is his little house over here. Not a straight line, right? The area that we're going to come up with for a trapezoid is generally an estimate, which is why we have a rule that we use. So it's h over 2 df plus dl. This is horizontal height, so the thing running this way, in between the two sides, over 2, brackets, side number 1 plus side number 2. So don't worry about knowing what df and dl mean. Just remember side number 1 plus side number 2. Okay, we're not answering a quiz, so you can ignore that. But for this one, we can do this question. So it would just be height, which is 52 over 2. And our sides are 43 plus 76. Our answer would be 3,094 meters squared. You have to do the squared. Okay, find the perimeter of the following shape. We're just going to run through a couple practice questions before we move on to our next piece of content in 5 minutes. Perimeter of this is going to be 45 times 2, because there's 245 millimeters, plus, and now look at our different measurements. Centimeters, millimeters. So let's do 4.5 centimeters times 2 plus 2.1 centimeters times 2. Now, why did I go to 4.5? Because there are 10 millimeters in 1 centimeter. So I can just pop a decimal place right there. I'm going to add these together. We get 13.2 centimeters. So 2.1, 2.1, 4.5, 4.5. Add them all together. We're now going to write out formulas regarding the calculation of area. I'm just going to show you guys these ones. So rectangle, length times breadth or width is also correct. Parallelogram. Now this is any shape that just has, now that would be a trapezoid, ignore that, 4 sides. So it can look like this, could look like this, could look like this. Any shape that has 4 sides that isn't one of our other, rhombus, kite, trapezium. Base times height, just generally speaking, base times height. Triangle, half times base times height. Now why is that? Because 2 triangles will fit inside the parallelogram. That would be base times height. So it's just half. Rhombus, half times the product of diagonals. These are diagonals. The lines that run diagonal to the edges. Kite, half times product of diagonals. Trapezium is our trapezoidal rule. H over 2 df plus dl. Circle, pi times r squared. Sector is the sector. So if we're looking for the sector of a circle and it tells us find the shaded portion, that would be 3/4 or 270 degrees over 360 times pi r squared. If we were asked to find this, it would be 90 over 360. All right, find the area of the following irregular shape. So let's first have a look at what we've been given. It looks like we've been given 2 triangles. So we're going to find the area of these 2 triangles. We're going to add them together. AC equals 22 meters. This middle line here is 22 meters. Area of a triangle, half times base times height. So let's do this triangle first. Half times our base, which is 22, times our height, which is 18, because we could flip the triangle around and it would look like this, 18, 22. We pop that into our calculator, half times 22 times 18, we get 198 meters squared. Our other triangle, half times 22 times 10, we get 110 meters squared. We add those 2 together, we get 308 meters squared. So it's important we just have the 2 triangles. These are what they'd look like if you drew them out. All right, using multiple applications of the trapezoidal rule, find the area of the figure below. So our trapezoidal rule, h over 2 df plus dl, or side 1, side 2. So you have 2 different trapezoids. First one, height 10, remember our height's the bottom, horizontal, over 2, 28 plus 25. Pop that into our calculator, 10 over 2, 28 plus 25. We have 265 meters squared. Other trapezoid, second one, 10 over 2, 25 plus 31. We get 280 meters squared. If we added those together, we would get 545 meters squared. Surface area of this closed end cylinder. Okay, closed end cylinder is area equals 2 pi r squared to find our 2 circles plus 2 pi r height. So 2 times pi times our radius. This is a 20 centimeter diameter, so our radius is 10 centimeters. 10 squared plus 2 pi times 10 times what's our height? 13 centimeters. That all goes in the calculator. 2 times pi times 10 squared plus 2 times pi times 10 times the height of 13. We get 1445.13. Didn't tell us to the nearest decimal point, so I'm just going to put it to 2. Or we can put it to 1. 1445.1 centimeters squared. We're looking for surface area. Surface area of this prism. So when we're looking for the surface area of a circle, let's run back to our formulas, because this is not one that they give you on the formula sheet. Sorry guys, takes a second. Okay, surface area of sphere. 4 times pi times radius squared. So remember, it's not the 4 over 3. 4 times pi times radius squared. So 4 times pi. What's our radius? Our diameter is 25. So our radius is half of 25, which is going to be 12.5 times 12.5 squared. Pop that in. We should get 1,963.5 centimeters squared. Very important. Diameter, radius is half. Okay, how do we smash measurement? How do we get full marks? Read every question very, very carefully. Take note of the units of the measurement, underline keywords, read the figures twice. Very, very important. Always double check your answer. So was it meters squared, meters cubed? Very, very important to make sure you're using the correct one. And always learn your formulas because they will not be given to you with the actual formula in it. So even if you go, okay, well, it's on the formula sheet. Do you know what 2 pi r squared plus 2 pi r h means? No. You need to remember your formula so you know what that formula means. Okay. What to include on your summary sheet. So these are all the things you've just run through. I've underlined the things that I find very, very, very consistently come up in year 12. So you need to know all your area calculations, your Pythagoras theorem, scale factor. Write down some examples of surface area of prisms, cylinders, spheres, and composite solids. Talk about volume and capacity. Talk about conversions. Talk about perimeters and irregular area, trapezoidal rule. Area calculations, Pythagoras, volume, capacity, trapezoidal rule are what I find come up the most in year 12 questions. So that's what I would emphasize in my revision. Not